OpenAI is spending $500 billion on AI infrastructure. Google is building data centers that are the size of a small city. Meta just ordered hundreds of thousands of GPUs. And here is what none of them will say on the earnings call. Say you buy 100,000 GPU and run them at 40% efficiency. Did not build a 100,000 GPU cluster. In reality, you just built a 40,000 GPU cluster and you paid the other 60,000 anyway. The first time I ran this number, I ran the calculation 3 times. Still 40% every time. This is not a software bug. This is not a management failure. This is a fundamental problem of coordinating machines at scale. And the bigger the cluster gets, the worse the problem becomes. A single GPU is like a world-class printer. 10,000 GPUs training together is like an orchestra. Every musician is world-class, but the orchestra only moves as fast as the slowest musician who has not finished their part yet. Right now, the AI industry is building the biggest orchestras in human history. And they have not yet solved the conductor problem, the gap that costs billions every year. I spent nearly a decade inside the semiconductor industry, from the world's most advanced chip maker to the labs of leading AI chip company. And one thing I kept noticing on both sides of the supply chain is the most important constraints almost never make into the public conversation. And what I'm about to cover in this video is exactly that kind of constraint. 4 things this video covers. First, let's see what's a GPU. A GPU can do millions of calculations simultaneously. One GPU is fast, but training a modern AI model on a single GPU would take years. So companies connect thousands of GPUs together into a cluster. And here is where the real problem begins. Every training step, each GPU does its math, then waits for the other GPU to finish before the next step begins. That synchronization takes time. At a few hundred GPUs, coordination overhead is negligible. But at 10,000, it starts dominating. Per GPU efficiency starts actively falling. Here's the insight that took me a while to fully accept. The bigger your cluster, the lower is the efficiency per GPU. That's Amdahl's law. And at 100,000 GPUs, the numbers are genuinely alarming. Your cluster is only as fast as its slowest GPU. Here is something that I've hardly seen discussed publicly, and it comes directly from inside the design process. There is no villain in this story, just the quiet math of competitive pressure, playing out the same way at every major company, every design cycle. When you build a chip, there's a priority order. First, the compute blocks, best engineers, most die area, most time. Second, the memory subsystem. Third, and this is the part nobody talks about, the communication architecture. The part that determines how the GPU talks to its neighbors. This gets whatever die area and the power budget is left at the end of the design cycle. Under scheduled pressure every time. Once that chip ships, the decision is locked. Cast in silicon. Every cluster built on that chip for next 3 to 5 years inherits this constraint. In a 100,000 GPU cluster, performance is not set by the fastest 99% of your hardware. It's set by the slowest 1%. At every training step, all GPUs must synchronize before the next step begins. That's the barrier at every step, and in reality, training includes millions of steps. So if one GPU is delayed, every other GPU in the cluster has to wait. A congested link, a defective memory chip, or one GPU runs a few degrees hotter. Every other GPU waits, every single step. 10,000 GPUs, all paused because of one slow connection. There is a single metric that industry uses to measure all of this. MFU, Model FLOPs Utilization. Every GPU has a rated theoretical peak speed. MFU measures how close to that peak you actually run, with all the coordination overhead included. When Meta published that number, my first reaction was not surprise. It was something closer to relief, that someone had finally said it out loud. When Meta trained Llama 3.1, one of the most advanced AI models ever publicly disclosed, by one of the best resource team in the world, they achieved an MFU of 38 to 43%. Think of it again. More than half the theoretical compute they paid was not doing any useful work. More than half. The 3 biggest sources of this reported. Memory stalls. The GPU is ready to calculate, but the data has not yet arrived from high bandwidth memory. In many AI workloads, GPUs are not compute bound, they are memory bandwidth bound. So waiting for the data is the biggest time-taking activity than really processing it. The resiliency tax. every few hours, something physically fails in a 100,000 GPU cluster. Engineers respond by checkpointing, saving hundreds of terabytes of model state to the same network used for training. When that fires, training and storage fight for the same pipes, pure waste of every single training run. ByteDance, the company which created TikTok, redesigned their entire cluster architecture to minimize all these losses. They achieved 55.2% MFU across 12,000 GPUs, industry's best publicly documented result. And still, nearly half the compute was idle every single hour. Now here is one of the most common questions that I get asked. Why does NVIDIA cap their NVLink domain at exactly 72 GPUs? The official explanation talks about switch port counts and signal integrity. Both are real. But there's a third constraint almost nobody discusses publicly: power. At every training step, all 72 GPUs trigger a synchronization at almost exactly the same moment. All of them spike their power draws simultaneously. All 72 at once, every step. The GB200 NVL72 rack draws roughly 120 kilowatts at peak. The power draw is about 80 average homes from a single rack. 72 GPUs is not an arbitrary number. It is actually a carefully calculated sweet spot. NVLink bandwidth is maximized and the simultaneous power spike is still within what rack can safely absorb. Scaling beyond 72 is not just a networking problem, it's a power integrity problem. Quick pause. If this kind of analysis is what you're after, where semiconductor engineering, geopolitics, financial angles, which most people miss, then please subscribe. Now here is the supply chain truth that almost never makes into the earnings call. This one took me the longest to put in words clearly. Not because it's complicated, because nobody says this directly. Everyone asks, why is AI hardware still so hard to get even when fabs are expanding? A GPU die coming off the wafer yields around 90%. Sounds good, right? But a modern AI chip is not just the one die. It's a GPU die bonded onto a large silicon interposer with multiple HBM stacks placed on top. Every assembly step has its own yield rate. Around 90% for GPU die, 85% for interposer assembly, 80% for HBM attachment, 90% for final package test. So you started at 90% for a GPU die, but we end up at roughly 55% of packages passing the inspection. You manufactured 100 chips, you shipped only 55, and the companies placing orders are pricing in the 100, not the 55. No company frames it that way publicly, but inside the industry, everyone knows. So what does all of this mean for where the value is being created? The real scarcity in AI era is no longer the GPU. It is the ability to run GPUs efficiently at massive scale. Arista Networks, routing the east-west traffic at the heart of every major AI cluster, hit $9 billion in revenue in 2025. Their AI networking segment is guiding to $3.25 billion in 2026 alone. Broadcom, making the switch silicon inside both Ethernet fabrics and custom AI interconnects, is the pick and shovel play regardless which GPU vendor wins. The real scarcity is no longer compute, it's coordination. Utilization is the real KPI. Modern AI training runs at 38 to 55% efficiency against theoretical peak. The other half is coordination overhead. Memory stalls, staggers, checkpointing, correlated power spikes. From outside, the AI race looks like a compute race, but underneath, it's a coordination race, a power race, a packaging race. We solved the compute, but now we are stuck on coordination. And in my opinion, the companies and countries that solve the coordination problem will capture the next decade of AI. I make these videos because there's a real gap between what actually happens inside semiconductor industry and what most people see in the news. If this gave you any value, please like and subscribe. It takes you a few seconds, but it really helped me to understand what you want more of. Thank you.